Hello friends, welcome to Align Pattern. In today's lecture, we will see detailed study about how to convert binary number system to decimal number and vice versa. So without further discussion, let's start today's session. Let's consider the example floating point number 53.625. Basically, a floating point number is a positive or negative whole number with a decimal point. For example, consider the number 53.625 and we want to convert this number into binary number system. So let's convert this number in the form of 0 and 1. So for the conversion purpose, first we have to separate this number into two parts. Okay. First part in this is the decimal number or we can say integer number, and second one is our fraction part or we can say float number. Now we have to convert first number 53 to binary and then we will move towards 0.625. Okay. So first step is to take decimal part and divide it by 2. Question arises here is why by 2? Because our binary number system has base 2. That's why we have to divide decimal part to 2 until we will get 0 along with taking remainder aside. So 53 divided by 2 we will get 26 and remainder we will get is 1. Again we have to divide 26 by 2 and again set remainder 0 aside. Again divide 13 by 2, we will get 6 and set remainder 1 aside. Okay. Then again divide 6 by 2, we will get 3 and set remainder 0 aside. Again we will go for division. Divide 3 by 2, we will get 1 and remainder we have is also 1. Again 1 divided by 2, we will get 0 and remainder is 1. Okay, so this is what we get as a binary number. If we reverse the value, so the binary number is 110101 and base we have to put is 2. In this way, we have to evaluate decimal number 53 to 110101 binary number. Next, we will see how to convert fraction part to binary number system. Okay. So, first step is to take fraction part, that is 0.625. So, for converting into binary, multiply this fraction part by 2. So, after multiplying by 2, you will get the result 1.205. Okay. So, this one we have to write it down. Again multiply remaining result as a 0.205 by 2. What we will get? Exactly 0.500. Again write down 0 aside. Again multiply remaining part, that is 0.500 by 2. Result will be 1.000. Write down the fraction part 1 aside. Next multiplication process will not be possible as we have 000 after that point. So we will stop and write down our respective numbers in downward direction. So what we will get? Result is 101 and base is 2. So the conversion of 0.625 of fraction part is 101 to the base 2. Okay, so 53.625 decimal number conversion in binary number system is 110101.101 to the base 2. So this is what actual conversion from decimal to binary number system. So now we will see binary to decimal number system. For example, consider the number 101111.1101. We want to convert to its equivalent decimal number, that is to the base 10. Okay, so it's very simple. Just note down the weights of 2 from right to left. Okay, so rightmost number here is 1. So we will write down 1 into 2 raised to power 0 as its weight. We will multiply weights by its given digit. Again, second digit is 1. So we will write down 1 into 2 raised to power 1 and get the answer 2. Third digit is again 1. So we will write down 1 into 2 raised to power 2, which we will get the result 4. Fourth digit is 1, so we will write down 1 into 2 raised to power 3, result we will get is 8. Okay. Likewise, fourth digit is 0, that gets 0 into 2 raised to power 4, ultimately gets the answer 0. Again next digit is 1, so we will write down 1 into 2 raised to power 5 is equal to 32. Okay, so we are moving digits from right to left and our weights of power 2 are going increasing as from 2 raised to power 0 to 2 raised to power 5. Okay, we know any number of power 0 is always equal to 1. So whatever we come across 2 raised to power 0 is equal to 1. 2 raised to power 1 means 2 into 1 equals to 2. 2 raised to power 2 is 2 into 2, that is 4, and 2 raised to power 3 means cube, that is 2 into 2 into 2. Takes 2 in 3 times and multiply it in simple term, which will get the result 8. Same way, 2 raised to power 4 is equal to 16, multiply by 0, ultimately gets the result 0, and at last 2 raised to 5 is 32. Okay, so whatever digit we have to add all the digits. So 1 plus 2 plus 4 plus 8 plus 0 plus 32 is equal to 47. Therefore, we will get 101111 to the base 2 is 47 in decimal conversion to the base 10. Now we will see how to convert floating point number to equivalent decimal part. So our fraction part is 0.1101. Here we will go from right direction after point. So at first 1 will be multiplied by 2 raised to power minus 1, which will get the result 1 by 2. If we simplify 1 by 2, then we will get 0.5000. Next digit is 1. We will be multiply 1 into 2 raised to power minus 2, which gives the result 0.2500. Multiply next digit 0 to the raised to the power minus 3 gives the result 0. Next digit is 1. Multiply this number into 2 raised to power minus 4, which ultimately gives the result 0.0625. All those results will get added and we will have in our bucket 0.8125. So our fraction point 0.1101 is converted in decimal point as 0.8125. Now just insert integer and fraction part to its place. As a result, 101111 is 47 in decimal and 0.1101 gives 0.8125. So our binary number 101111.1101 to the base 2 is converted into 47.8125 in decimal, that is in the form of 2 the base 10. So here we have a decimal to binary conversion and binary to decimal conversion. I hope you will get the concept and be prepared for your next exam, and wish you all the best. Thank you so much for watching the video. Please like and subscribe the channel and do motivate me to make such videos. See you in the next session. All the best.